So this is our unit 2nd, comparative chemistry of main group element from chemistry paper 2nd, okay, of FYBSc semester 1st. So what is the comparative chemistry of main group elements? In this topic we are going to see what different substances are formed by the reaction of group first and second element. Okay, again some of the important substances which we are using in our day-to-day life, okay, and which contains the alkali and alkaline earth metals. Okay, apart from that, or in addition to that, we are going to see that what are the pollutants occurs in the nature or forms in the nature, okay, in presence of these elements, okay, and what are their health hazards. So here we are starting the comparative chemistry of main group element, in which we are going to see here the carbides of group first and second element of periodic table. So group first element are the alkaline metals and group second are the alkaline earth metals. Okay, so how they forms carbide? So binary compound of carbon in which carbon react with the more electropositive metals are called carbide. When lithium is heated with the carbon, an ionic carbide is formed, that is Li2C2. Okay, and other metals also forms the carbides when they heated with ethine. So here when lithium heated with the carbon, it forms a lithium carbide. But when sodium heated with ethine, it forms a carbide of sodium. Okay, metal like potassium, rubidium, cesium react with the graphite and forms highly colored interstitial carbide. Which element? Potassium, rubidium, cesium. Okay, they react with the graphite. Okay, the most important reaction of carbide with the water is when they give the mixture of ethine. Where the ethine is formed? See, when sodium carbide heated with the water, it gives ethine. Okay, now see, means when this product heated with the water, it gives ethine. Okay, so when calcium carbide is heated with metallic oxide or halides, okay, so carbides are obtained. See, calcium carbide when heated with the magnesium oxide, and here calcium carbide heated with magnesium halide. At both the places they are giving the corresponding carbide of that element. Okay, so this is what the magnesium carbide. Here is again magnesium carbide. So alkali metal carbides are the soft. Beryllium carbide, that is Be2C, is so hard it can scratch the glass and the quartz. Okay, here it is. In solid state, the carbide are non-conductor of electricity. When they are in the solid state, they are non-conductor of electricity. But when they convert to the liquid state, they may conduct the electricity. Okay, due to that, such a sentence is written over here. Now nitrides of the group first and second element. Okay, in the first slide we have seen the carbides. Now we are going to study the nitrides. Okay, so nitrogen form binary compound with the element similar or lesser electronegativity. Okay, the elements which are having electronegativity same as that of nitrogen, or the electricity less than the nitrogen, they react with the nitrogen to form a nitrides. Okay, and they contain nitride ion, that is N3 minus. So there are three types of nitride, that is ionic nitrides, covalent nitride, and interstitial nitride. So lithium react with the nitrogen gas to form lithium nitride. All alkaline earth metal forms a nitride with the formula M3N2. See here, magnesium react with nitrogen gas to form Mg3N2. Okay, again by heating imides and amides of any element, that is element of group second or first, they forms Here they have shown here the second group element. They forms a corresponding nitride. See here, Ba twice NH2. Okay, that forms a barium nitride. Okay, and here is a evolution of ammonia gas. Here is again amide of calcium is there, so that again forms calcium nitride. Okay, so nitride react with the water and undergoes hydrolysis to produce a ammonia and the metal hydroxide. See here, magnesium nitride react with the water to form magnesium hydroxide. So magnesium nitride decomposes at the temperature about 270 degrees Celsius, while beryllium nitride melts at a 2200 degrees Celsius without its decomposition. Okay, magnesium nitride undergoes decomposition, but beryllium nitride does not undergo the decomposition. Okay, after that we are going to see the oxides, peroxides and superoxides of the group first and second metal. Okay, so oxides, now see here, lithium react with the oxygen to form normal oxide. Then sodium peroxide reacts with the sodium metal to form a normal oxide. Rubidium react with the oxygen molecule to form superoxide. Okay, so here it is again. Lithium oxide react or treated at 400 degrees Celsius. It forms a lithium peroxide. So monoxides are ionic in nature. Okay, so lithium oxide, sodium oxides are the pure white solids. Thus we can say that oxides and peroxides are colorless when in the pure state, but the superoxides are yellow or orange in color. Okay, but surprisingly potassium oxide, okay, is a pale yellow in color, rubidium oxide is bright yellow in color, and cesium oxide is orange in color. These metallic oxides are easily hydrolyzed by water to form corresponding hydroxide. Okay, and that are the strong bases. So see, lithium oxide react with the water to form a lithium hydroxide. Okay, again, see, these superoxides react with the water to form corresponding metal hydroxide. Here is again superoxide. This is peroxide. This peroxide react with the water to form corresponding hydroxide, and the superoxide react with the water to form corresponding hydroxide. So peroxides are diamagnetic in nature. Okay, and they are oxidizing agent. Superoxides are paramagnetic in nature and they contain O2 minus ion. Okay, they are colored. So what are the uses of the oxides? What are the uses of these oxides? Okay, see now, sodium peroxide is widely used as an oxidizing agent. Okay, it is also used for the bleaching of wood and fabrics. Then calcium peroxide is used as a bleaching agent and also used as an antiseptic. Then potassium oxide is used as a space capsule or in submarines for the breathing of mask, in the breathing mask. Why? Because it produces dioxygen by the removal of carbon, dioxide. Okay, so this is what the reason why space in the spacecraft, okay, or the under the water, the use of these oxides is common, right? So after that, group second metal. See now, oxides, that is MO, okay, of alkaline earth metal are obtained either by heating the metal in presence of oxygen or by the thermal decomposition of corresponding carbonate. See here, metal, that is beryllium, magnesium, calcium heated with the oxygen gas, they forms a metal oxide, and this is a metal carbonate. When heated, they forms a metal oxide. Okay, the metal may be beryllium, magnesium, calcium, strontium and barium. Okay, so beryllium is a basic and covalent in nature, and all other oxides are extremely stable ionic solid due to their high lattice energy. Other oxides are having high lattice energy and hence they are the ionic solid which are highly stable. Okay, Beryllium oxide has very high melting point because of its polymeric nature. Beryllium oxide is a polymeric in nature and hence having high melting point. All these oxides except the beryllium oxide react with the water to form sparingly soluble hydroxide. Sparingly soluble hydroxide. Okay, as atomic number increases from magnesium to barium, the solubility, then thermal stability, and the basic character of their hydroxide also increases. Means from the top to bottom, hydroxide forms, their solubility increases, thermal stability increases, and basic character also increases. The peroxide of alkaline earth metal except beryllium are obtained by heating normal oxide with the oxygen at very high temperature. Okay, see here, barium oxide when heated with the oxygen, it forms superoxide of barium. Okay, superoxide of barium. So where these are the use? So alkaline earth metal oxide are very good conductor of heat. Okay, then they are chemically inert and act as an electrical insulator. They are used as an electrical insulator. Therefore, these oxides are used for lining the furnace and hence used as a refractory material. Magnesium peroxide and calcium peroxide are used as an antiseptic and bleaching agent. Antiseptic and bleaching agent. Then barium peroxide is used as a bleaching silk and vegetable fiber. Okay, vegetable fiber. Okay, after that peroxide ion is there. So this will continue in the we will continue in the next lecture. Okay, thank you.